Hey there, and welcome to this explainer. If algebra has ever made you feel, well, a little intimidated, I just want you to take a deep breath. Seriously, relax your shoulders. Today, we're going to dive into a simple, everyday puzzle that makes high-level math incredibly easy to understand. I always tell my students that math really isn't something to be afraid of. It's not just a bunch of random rules. It's simply a language we use to solve real-world mysteries. And believe it or not, the exact math we're exploring today is used literally everywhere. We're talking figuring out shopping discounts at the mall, measuring land for farming, mapping out architectural designs, and even calculating your monthly phone data usage. And the best part? We're going to look at the shape and the logic of these puzzles visually, long before we ever touch a single formula.
All right, let's dive right into this. We're going to start with an easy example, a completely real-life shopping mystery. Let's break down exactly what's given to us here. So Siri goes to a bookshop. She buys 3 notebooks and 2 pens, and the cashier tells her the total bill is 80 rupees. Okay, so what is being asked of us? We need to find the exact cost of just one single pen. If you think about this situation, it kind of feels like a detective case, where you've only been handed half the evidence, right?
Now here is absolutely the most common mistake I see students make in exams. When faced with this exact setup, people immediately try to just guess the answer from this one single clue. For instance, someone like Rubina might guess, okay, maybe a book is 25 rupees and a pen is 2 rupees and 50 paisa. If you do the math, that perfectly adds up to 80 rupees. But then Joseph chimes in and guesses a book is 16 rupees, which would totally leave enough room for the pens to also make the total 80 rupees. Do you see the problem? With just one equation but 2 unknown items, there are simply way too many possibilities. We're literally just stuck in a guessing game.
So here's the catch. To find a unique, definite solution, we always need a second piece of the puzzle. In math terms, this means we need a second independent equation. Enter Siri's friend, Lakshmi. Let's say she bought the exact same types of items from the exact same shop. Her given information is that she bought 4 notebooks and 3 pens, and her total was 110 rupees. Boom. Suddenly, the fog begins to lift. We now have 2 completely different situations involving the exact same hidden prices.
Okay, let's visualize this whole thing before we even think about using any confusing formulas. We call this the model method. I want you to just completely forget about X and Y for a second. Instead, let's use tall purple rectangles to represent the cost of our books, and shorter, blue hatched rectangles to represent the pens. By actually assigning physical shapes to these items, we can visually see the weight of the problem.
Picture a split screen in your mind. On the top half, let's place Siri's shopping basket. We've got 3 purple books and 2 blue pens, all neatly packed into an 80 rupee box. Right below that, let's place Lakshmi's basket. 4 purple books, 3 blue pens, filling up a 110 rupee box. We're building our evidence step by step here. Looking at it, we can clearly see that Lakshmi bought 1 extra book and 1 extra pen, and it cost her 30 rupees more. But honestly, that still doesn't separate the book price from the pen price for us. We're going to need a clever trick.
And this right here brilliantly illustrates our underlying logic, proportional reasoning. It's not just about how to solve it, but why it works. If we want to find the price of one item, we need to force the other item to be exactly the same in both baskets, so we can just ignore it. Let's target those pens. Siri has 2 pens, Lakshmi has 3. Well, what if we multiply Siri's entire shopping trip by 3? And what if we multiply Lakshmi's entire shopping trip by 2? We are slowly, deliberately building our solution by scaling up their purchases. By doing that, we magically balance the scales to have exactly 6 pens in both scenarios. It's like finding a shared frequency. Siri's multiplied trip gives us 9 books and 6 pens for a total of 240 rupees. Lakshmi's multiplied trip gives us 8 books and 6 pens for 220 rupees. Why is this so powerful? Because now the number of pens is absolutely identical. The only difference between these 2 massive shopping trips is the number of books. So what does this actually mean for us?
Well, by comparing these 2 new totals, those 6 pens completely cancel each other out. Since they're identical, they don't contribute to the difference in the final price tag at all. Siri has 9 books, Lakshmi has 8 books. The difference is exactly 1 extra book. And the difference in their total bill? That's 240 rupees minus 220 rupees, which is exactly 20 rupees. We just peeled away the entire mystery. 1 single book costs exactly 20 rupees.
All right, now we can breathe easy. We just calmly take that 20 rupees and plug it right back into Siri's original basket. We know Siri bought 3 books. At 20 rupees each, that's 60 rupees for the books. Her total bill was 80, right? So the remaining 20 rupees must be for her 2 pens. And, hey, if 2 pens cost 20 rupees, that our mysterious single pen costs exactly 10 rupees. See what we did? We solved it by making one item equal, finding the cost of the other, and working backward.
Guess what? You just did advanced algebra without even breaking a sweat. What you just solved is formally known in textbooks as a pair of linear equations. The golden rule here is simple, but absolutely non-negotiable. Whenever we have two unknown variables, like a book and a pen, we absolutely need two independent linear equations to find a unique solution. One equation is just a guess. Two equations give us the concrete truth.
Okay, let's switch gears and see how this builds into another situation. Imagine you're at the local vegetable market. What is given to us is this: 1 kilogram of potatoes and 2 kilograms of tomatoes cost 30 rupees total. What is being asked is the individual price per kilo for each vegetable. Based on what we literally just learned, what are you missing to find those individual costs? Like, could you solve this right now?
If you said, "No way, I can't solve it yet," you hit the nail on the head. You absolutely need that second shopping trip a few days later to complete your pair of linear equations. So here is your second clue. 2 kilos of potatoes and 4 kilos of tomatoes cost 66 rupees. Now you've got two unknowns and two distinct equations. You have everything you need to balance the puzzle, exactly like we did with the books and pens.
Let's look at a medium-level setup. Imagine a high school cricket coach goes shopping for gear. Clue 1. He buys 3 bats and 6 balls for 3,900 rupees. Later on, clue 2. He buys 1 bat and 2 balls for 1,300 rupees. Just like measuring land or figuring out data limits, we are taking a real-world text paragraph and translating it directly into math. Writing out these clues as equations is always step 1 in an exam. But wait, look closely at this one. Notice anything funny? 3 bats and 6 balls is actually just 3 times the size of 1 bat and 2 balls. And 1,300 times 3 is exactly 3,900. These equations are actually describing the exact same pricing ratio. It's literally the same clue twice. So while the math shows his purchases are perfectly consistent, we'd actually need a truly independent second clue to nail down the individual prices.
All right, feeling confident? I genuinely think you're ready for this. Let's tackle a hard, board exam level multiple choice question straight from the source material. This is where we test if we really understand the shape and the rules of the math, rather than just blindly crunching numbers. Let's read this carefully. The question asks, which of the following is not a linear equation? We have 4 options here with different arrangements of x and y. I want you to think about the word linear. It literally has the word line right there in it. A linear equation, when you draw it out on a graph, should only ever create smooth, straight lines. It represents a steady, constant relationship, like a fixed price for a pen.
Yep, you totally nailed it. The correct answer, meaning the one that is not a linear equation, is option C. But why? Look really closely at that y. It has a little 2 floating right above it. It's squared. That little square instantly disqualifies it. Exponents like squares or cubes, they create swoops, curves, and parabolas on a graph. They absolutely do not belong in our straight-line, linear world where we are just multiplying a set price by a quantity.
Okay, as promised, here is your quick 5-point cheat sheet summarizing everything we've talked about. Number 1, the standard format you'll see in textbooks looks like ax plus by plus c equals 0. Number 2, those letters A, B, and C, don't let them scare you. They are just real numbers, like our rupee prices. Number 3, the absolute golden rule is that A and B cannot both be 0 at the same time. Otherwise, our unknown items just disappear completely. Number 4, the fancy math way to write that golden rule is A squared plus B squared does not equal 0. And finally, number 5, our biggest takeaway. If you have 2 unknown variables, you must have 2 independent equations to solve it.
And before we wrap up, here is a surprise trick to help you fly through exams much faster. I like to call it the balancer. Instead of doing long, complicated substitution formulas, always look for the easiest proportional reasoning first. Look at your 2 equations, find the item with the smallest numbers, like those pens in our very first example, and just multiply the whole line until those specific items match perfectly. Once they match, you just subtract one equation from the other, instantly cancel that item out, and you can solve the rest in seconds. Remember, math isn't some scary set of rigid rules you have to memorize just to pass a test. It's actually a highly effective toolkit for balancing and solving everyday mysteries. You now know exactly how to spot the clues, build your equations visually, and balance the scales.
So now that you have these tools to decode the math hiding in plain sight, what real-world mystery are you going to balance next? Thank you so much for joining me in this explainer, and keep exploring.